All right, so what this is all about is how pictures, Matt, if I may have your attention, how pictures are just oh so useful in solving problems. And so the way this is going to go is when I give you an assignment, if you have questions on the assignment, you need to draw the picture first before I will answer any of your questions. So you can't just read the problem and then just go, I don't get it. You have to read the problem, at least try to draw a picture diagram that goes with it, and then we can work this out a little bit to get you to where you need to be. The pictures are a great way to help you visualize and understand the problem better. For example, let's start, Jacob, with this little brain teaser. It says volumes 1 and 2 of a 2-volume set of math books sit next to each other on a shelf. So maybe like some books over there, there's volume 1, volume 2 on the bookshelf right next to each other, right? The normal way, okay? They sit in their proper order, volume 1 on the left and volume 2 on the right. Each front and back cover is 1/8 of an inch thick. So this cover right here is 1/8 of an inch thick, and this cover right here is 1/8 of an inch thick. Capiche? All right. And then it says the pages portion of each book is 1 inch. So you're picturing the 2 books, volume 1, volume 2 on the shelf, side by side. Okay, we got all their specs. All right. Then it says a bookworm starts at the first page of volume 1. So page 1, volume 1, and eats its way through till it gets to the, oops, volume 1, till it gets to the last page of volume 2. How far did it travel? How far did he eat? I have heard one guess of 3 inches.
2 inches and 2/8.
2 inches and 2/8, and another way of saying 2/8 is 1/4. Okay. Oh, got another 2.5. Cameron? 2.5. 2 1/4. 2 3/8. Okay, are you ready? Let's draw a picture and see if the picture helps us solve the problem.
No.
Okay, so here is volume 1 sitting on the shelf.
That's a nice book.
It's a good book, it's a classic. So there's volume 1, and then right next to it is volume 2. They're supposed to be the same thickness. Okay. Where did the bookworm start eating?
Page 1.
Page 1 of volume 1. Where is page 1 of volume 1?
On the very left.
On the very left?
Right.
Look at it. Think about it.
That's the cover.
Oh,
Where is the first page of volume 1?
Right.
I am not a cheater. The first page of volume 1 is right there. Page 1. Okay? Think about it. If I take this book right here, it's facing you just like that one is right there. The first page is on the right side, not the left side, right? Okay? Oh, it gets worse. Where is the last page of volume 2?
What? So it went through 1. That's bull.
The last page of volume 2 is right there.
So count
So how far did it go?
2/8.
2/8 of an inch. It went through 2 covers. That's it. So 2/8 of an inch or 1/4 of an
Okay,
inch.
that wasn't cool.
Okay. Do you see how helpful it was to make a picture?
No.
No? You're not convinced? Well, let's do another one then. All right, let's try another one. See if this convinces you.
Picture. Okay, I'm ready for this.
All right. Harold, Dina, and Linda are standing on a flat, dry field reading their treasure map. Harold is standing at one of the features marked on the map, a gnarled old tree stump. So here's this tree stump here. Okay, and Harold is standing at that tree stump. Let's move Harold a little bit more into this.
Perfect.
Okay. Then we have Dina.
Exactly.
So now it's all set.
It honestly
Dina is standing on top of a boulder over here, okay? And these two objects are 80 feet apart. According to the treasure map, here is what we know. The treasure is 60 feet from the tree stump, and the treasure is also 40 feet from the boulder. How many places do Harold and Dina have to dig in order to be sure that they will find the treasure? You're going with 2? How are you coming up with 2, Michaela? Oh no, I'm loving 2. Talk to me about 2.
Why is it right?
Yeah, it is right. It is right. If it is 60 feet from that stump, what do all of the places look like that the treasure could be if that's all we know? Not a triangle, a circle. Because in a circle, all the points are the same distance from the middle. So if all we knew was that it was 60 feet from that stump, we could draw a 60-foot circle around that stump, dig a trench, and somewhere in there would be the treasure, right? Okay? But couldn't we say the same thing about from where Dina is?
No.
Right? Right, so hers is the same shape, but it's closer. Hers is only 40 feet away from her, from her boulder. Okay? So it's got to be somewhere on that circle. So how many places are there where the treasure could be? There are 2 places where the treasure could be. All right? But what about Linda? It doesn't say anything about Linda. Have you ever heard of triangulation? Yeah? If they had a third point, if Linda was out here somewhere and she had some information too, these 3 points make a triangle, okay? And if we drew a circle from Linda's spot, how many points would that narrow it down to now? 1. Either her circle would intersect this point right here or this point right here. And that's called triangulation because you need 3 points to do it. And that is how they locate things like the epicenters of earthquakes, because they have 3 different stations that measure it, and they say, well, we know it was this far from us, and they say, well, it was this far from us, and then somebody else says it was this far from us, and that means it must be right here. Same thing with radar. If a ship is lost or something like that, or trying to find something, they can use triangulation to narrow that down to exactly 1 point. Okay? So how much fun is that? Pretty dang fun. Okay, the last thing then you need to know about, and according to 4th period, you're all very familiar with these, so that's good. Is the idea of a Venn diagram. I did not realize this was something that you used in English class, but that's awesome. We are going to make a Venn diagram for the following 4 types of quadrilaterals: parallelograms, rectangles, square, and the other weird one, which is a rhombus. Okay, so for those of you who have not seen a Venn diagram, here's how it goes. What is the broadest, biggest category of all 4 of those things? Which one is the biggest? Parallelogram. And so what I'm going to do is I'm going to take and draw a big old circle. That's an oval, so I'm going to draw a big old oval, and I'm going to say everything inside of this oval has to be a parallelogram. Okay? All right, now the next thing is rectangles. Is every rectangle a parallelogram?
Yes.
Yes. So where does my rectangle circle need to go?
Inside.
completely inside my parallelogram circle. Okay? So since every rectangle is a parallelogram, the rectangle circle needs to be completely enclosed inside of the parallelogram circle. And now I'm going to skip squares and I want to talk about rhombuses. Are all rhombuses parallelograms? What? Yes, all rhombuses are parallelograms. So the rhombus circle must also be inside the parallelogram oval. However, are any rhombuses rectangles? What's the definition of a rhombus? 4 congruent sides. Okay? What's the definition of a rectangle? 4 congruent angles. Yeah. Okay. Can you have a parallelogram that has 4 congruent sides and 4 congruent angles? Yes. And so since that can happen, that means that my rectangle circle and my rhombus circle must overlap. What do we call the place where they overlap? What are shapes called that are both rectangles and rhombuses at the same time? Squares. And so there's my Venn diagram for those 4 quadrilaterals. Okay? And we left some out, and we left them out because they're boring. Where would a trapezoid go? Are trapezoids parallelograms? No, they can't be. They can only have one. So they would just have a funny little circle out here by themselves. What about kites? Are kites parallelograms? No. Are kites trapezoids? No. So they would be outside there too. So that's not really very interesting. Okay? Okay. All right, so don't forget, draw a picture first. Draw a picture first, and then you can ask for help.